here we go. We're doing right triangle trigonometry today. We're solving right triangles. Here's the nice thing about right triangles, and it only works for right triangles. If you have a right triangle and have one side and two other parts, there's 6 parts to a triangle, 3 angles and 3 sides, right? Right triangle, one of the angles is set at 90 degrees. So you have 5 other parts, 2 angles and 3 sides. If you have one side in any of the other 2 parts, you can find the rest of it. That's the really nice thing about right triangles. If you have one side length and any other 2 parts other than the 90-degree angle, because that's a given because it's a right triangle, so either one of the two, you have the two triangles and the other 2 sides, or angles and the other 2 sides. If you have any of those other parts, 2 of those parts, you can find the other parts. That's a really nice thing about right triangles. Now, there are ways of finding missing parts of non-right triangles. They are much more complicated. They are not something that we do in this class. Even if we weren't short for time, we would not be doing the law of sines and the law of cosines. We'd only be doing the right triangle stuff. Some of this you've already done. Oh, before we get too carried away, and I am recording good, get out your calculator. I need a pen to write with first. There we go. Take the sine of 45 degrees, and that should be 0.707 is what you should get. Do that on your calculator. Take the sine of 45. Make sure you're getting 0.707. If you're not, you're in the wrong mode. I think it's 0.84 something, but I can't remember exactly. If you're in the wrong mode, you need to be in degree mode. If you take the sine of 45 and you get 0.707, then you are in degree mode and everything's good. If you're getting something other than 0.707, you're in the wrong mode and all your answers will be wrong. You're in radians and all your answers will be wrong. So you should have on mine this bigger keypad, but the same thing is probably in the same area. S-I-N, that is not sin. Sin is what you talk about in church. This is not church. This is a math classroom. We do not sin in here. We use sine. Okay? You have sine, cosine, and tangent. So the S-I-N button, hit sine, type 45, hit enter or equals, and you should get 40. You should get 0.707. If you're not, then your calculator's in the wrong mode, and we need to fix that before we go any further, because you will get all the wrong answers. And it would really, 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 really suck to get all the wrong answers because you were in the wrong mode. Okay? And the difference is radians or degrees. You use degrees in geometry, you use degrees in here. When you get to pre-calculus and calculus, everything's in radians, no longer in degrees. Just, it is what it is. And it depends upon, after that, practicality of application. But yeah, you have to do that. Make sure you're sine of 45 degrees. So, one of the old standbys is the Pythagorean theorem. We'll have to wear a Pythagorean theorem t-shirt for tomorrow's class. A squared plus b squared equals c squared. By the way, that is named after Pythagoras not because he was the first one to understand the relationship between the 3 sides of a right triangle, because he was the first one to attach his name to it. First one to have it published in your name is the first one that counts as having it be your theorem. Technically, that's what happened. It's called the Pythagorean theorem, but no, he wasn't the one that came up with that concept. We know for an absolute fact that the idea of the square of the hypotenuse being equal to the sum of the squares of the other 2 sides, which is what you get, existed long before Pythagoras even his civilization existed, let alone him. There's an ancient Babylonian tablet that predates Pythagoras by like 500 years that has lists of Pythagorean triples. There is no way you come up with a list of Pythagorean triples if you don't understand that concept. Predates him by a long shot. He's just the first one to put his name to it. There are theories about who actually formalized it, because he's given credit with formalizing it, but there's actually a lot of theories about there that he wasn't even the one that formalized it. Not to say that Pythagoras wasn't extremely important in mathematics. He was one of the early ones of actually formalizing mathematics, and it's a big deal. He was a very huge person in early math, but he gets a lot of credit for something here that he didn't do. He just put his name to it. Okay. Then we have our trig functions. Okay. Now these trig functions, notice down here it says only used on right triangles. SOHCAHTOA. How many of you have heard of SOHCAHTOA before? Okay, I don't like SOHCAHTOA. Well, I kind of like it written out like that, but I don't like SOHCAHTOA. Here's how I remember which one it is. You have sine is the opposite over the hypotenuse, cosine opposite over hypotenuse, tangent opposite over adjacent. I don't say SOHCAHTOA. Here's what I say. And this will help you remember it correctly. Some old hippie caught another hippie tripping on acid. You'll remember that, won't you? You already remember that. I only said it once. Some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. SOHCAHTOA doesn't work because a lot of students drop the H on the so and the co. They screw that up. Or they see that co, so, ka, they don't say this right, they have the O on here again, so they do the same thing. You're not going to screw it up. Some old hippie. You're not going to forget some old hippie. Caught another hippie. You're not going to forget that. Tripping on acid. Now you're teenagers. You remember all these stupid drug jokes. Everybody does. Everybody gets that. You will not forget that setup. So what does that mean? Okay. Now, I'm not going to worry about the ones on the bottom. There are 6 trig functions. We have sine. This is not sin. If you say the sin of something, I'm going to be very upset with you. Okay? And committing the sin of having angry thoughts towards you. Sin is for church. This is a math classroom. This is sine. Okay, this is the sine, cosine, and tangent. Not sin, cos, and tan. Ooh, that makes me angry. These other ones down here we won't be using in this class. Cosecant, secant, cotangent. Can an elephant drive a Cadillac? Of course he can't. Okay, so sine, cosine, and tangent. How do they relate to triangles? Okay, well, we're going to work on that here. So let's go back down to this one down here. Standard labeling for triangles. And this is kind of important that you get this, and you should have covered this in your geometry classes. Standard labeling of any polygon is capital letters for the vertices, lowercase letters on the opposite sides for the sides. Generally speaking, for a right triangle, 2 vertices that are not right are capital A, capital B, capital C for the right angle. That's usually how it works, but you can use any 3 letters you want, but this is standard. The sides that are opposite are lowercase. So angle A, the side opposite angle A, is side A. Angle B, side opposite, is side B. Angle C is side C. And by the way, that side C has a special name. What is the special name for that side? Hypotenuse. Only right triangles have hypotenuses. The hypotenuse is always the longest side in a right triangle. It's the side opposite the right angle. Okay. Now, if we go back to here, we can use these. This is how you label up the sides. The signs, opposite, over, adjacent, things like that. Let's go ahead and go to the next slide. Any questions before moving on? Like I said, you did all this in geometry. This should be review, or you should have done this in geometry. You may not remember everything from it, because this is one of the things that's supposed to be covered, but it doesn't always get covered correctly. So, Determine the value of all 6 trig functions, and we're not going to do all 6. We're only going to do sine, cosine, and tangent. I'm not going to worry about the cosecant, secant, and cotangent. We're only going to worry about the first 3 on here. The other ones do have their places, but we don't need them for anything we're doing in here today, so I'm not going to worry about it, okay? The idea is if I have an angle and I have sides, I can set up the trig ratios based upon that. And that's what sine, cosine, and tangent are. They are ratios. You have an angle, and for example, the sine of angle theta, in this case, and that's theta, by the way, that's how you say that. That's the most common variable that you use for an angle is theta. There's a couple of other ones, but theta is the most common variable for angle. If you see theta, 99.9% of the time it's referring to an angle measurement. Okay? It's like x is your most common variable for numbers. Theta is by far and away the most common for angle measurements. So I have my angle theta right here. This is my angle theta. The sine of angle theta is the ratio of 2 of the sides in the right triangle. Remember sine, some old hippie. O for opposite, H for hypotenuse. Sine is opposite over hypotenuse, some old hippie. SOH, sine opposite over hypotenuse. So, angle theta, what do I mean by opposite? Angle theta is here. This is the side that is on the opposite side of the triangle from it. So my angle theta, or sorry, my sine of theta is the side opposite, 6, over the hypotenuse, which is always along the side, over 10. And what do? Always reduce. 3 over 5. Always reduce. Cosine theta. Caught another hippie. Cosine, caught another hippie. C for cosine, another for A, H for hippie, right? Cosine is adjacent over hypotenuse. Now, students will often get confused over adjacent because there are technically 2 sides of this triangle that are adjacent to angle theta, right? Because you got the angle and then you got 2 sides and the angles between. That angle's adjacent to this side and adjacent to that side, but only one of them is a side, the other one is the hypotenuse. So the adjacent side is this one here. So my cosine is 8 over 10. The side adjacent to the angle that's not the hypotenuse over the hypotenuse. And what do we always do? We always reduce 4/5. And then the tangent, tripping on acid, TOA, tangent, opposite, adjacent. So it's the side opposite the angle over the side adjacent to the angle. Which one is opposite? 6. Which one's adjacent? 8. So my tangent would be 6, 8, which would be equal to 3/4. Okay? That's setting up the ratios. And if you can do that, you can do an awful lot. Okay, this is key to being able to find missing angles. So, looking at the other triangle, we can do this on the other triangle, but we got a problem, don't we? What's going on the second triangle? What's going to screw me up on this one? I'm missing a side, aren't I? Yeah. And I can't set up ratios if I don't have a side. However, it's a right triangle, and if I have 2 sides, what can I use to find the third one? Pythagorean theorem. So, that's all you have to do. I need to figure out what this side here is. I'm going to call it x for the moment. Now, students often mess this up by not paying attention to what I have and what I don't have when I'm setting up the Pythagorean theorem. A squared plus b squared equals c squared. That c squared is the hypotenuse. Students will often set it up so that way, what you're looking for is x. So the first one, second one, they would take 5 squared plus 8 squared equals x squared, which is wrong. It's the two sides, x squared plus 5 squared equals 8 squared, and that's what you solve. So, stop doing that to me. X squared plus 25 equals 64. Subtract 25 from 64, that's 44 minus 5, 39. X squared equals 39. So x equals the square root of 39. And don't make it a decimal. Just go ahead and leave it the square root. That's fine with me. And you cannot simplify the square root of 39 because that's 3 times 13. Neither one of those can be simplified, so you're done. Now I have what I need to set up my 3 ratios. So please take a second, set up the sine, cosine, and tangent of theta for that triangle there. Some old hippie caught another hippie tripping on acid. Like I said, for now, just leave it as a square root of 39. And don't worry about simplifying any rest. Oh, you don't have to worry about that here anyway, so don't mind that. Scratch that. Okay, so 5/8 root 39, so the sine would be the square root of 39 over 8 over 8. Stop doing that. Cosine would be 5 over 8, and the tangent would be the square root of 39 over 5. By the way, the cosecant, secant, and cotangent, if you can find these 3, those are easy. If you go back over to the first one we did, the sine is 3/5, the cosecant is the inverse of that, 5/3. The cosine is 4/5, the secant is the inverse of the cosine, 5/4. And the tangent and cotangent, same relationship, 4/3. You're not going to be using that in here, but I thought I'd just kind it out. Those are all just inverses of the element, or I should say reciprocals is a little bit more accurate than inverses. They're all reciprocals. It's interesting though, the sine is not secant and sine, and no, it's sine and cosecant, cosine and secant. And I saw somebody explain to me once, very briefly, a long time ago, why it's that way, literally 20 years ago. And I didn't write it down. I should have written it down because I don't remember what there's a really simple explanation of why they are inverted that way, why they're labeled that way. I forgot. Okay. So, I think we're good on doing that, labeling up sine, cosine, and tangent from there. Let's go to this one. And this is just making sure you know how to use your calculator properly. So, here's what I want you to do. We're going to turn it on. Take the cosine of 54 degrees and the sine of 17 degrees, and the tangent of 25 degrees. Take a minute to write them down. And how many decimal places does it say to go? 4. That's standard. Standard is 4. Usually it's 3 decimal places for almost anything. This is one of those ones, 4 decimal places is standard for trig functions. When you're using decimals for trig functions, 4 decimal places is standard for your accuracy. So, 0.5878 rounding. The sine is 0.2924 rounded. And the tangent is 4663, 0.4663. By the way, the tangent is the only one that you will get a number larger than 1. Sine and cosine are never larger than 1. Tangent can be larger than 1. Sine and cosine are never larger than 1. There are always positive values in what we do in here. Okay. Questions on that? And that's just to make sure you know how to use your calculator kind of thing. It's not that hard. Okay. Now, there is something that is not written on there that I want you to do. I want you to find the inverse cosine, 0.5878. So, see if you can locate it, figure out on your calculator the inverse cosine. Do it. What do you get? Ooh, no, you should not get that.
Oh, I did the numbers wrong.
You did the inverse sine?
No, I just missed the number.
Oh, okay. So 0.5878. You should get back 54 degrees, or on your calculator, 53.998 something, which is, if you round it off, it'll give you 54 degrees. We are going to be using inverse trig functions in here. Inverse trig functions, normally when you see something like cosine of the negative 1 power, what does that mean? That means 1 over the cosine. Not with trig functions. You see trig function of a negative 1 power, that is not 1 over that trig function. It's the only time it's not 1 over something is basically with that. Those are inverse trig functions, and what they do is it's undoing. It's like the difference between squaring and square rooting. It's the undoing of each other. Inverse trig functions give you the, if you take the inverse trig function of the ratio, it gives you the angle. That's how you can find the angles in right triangles if you're not given one. If you have the sides, you can find an angle by using an inverse trig function. And so you'll see sine of the negative 1, you'll see cosine of the negative 1, you'll see tangent of the negative 1 on your calculators. That's not 1 over the sine, it's not 1 over the cosine, it's not 1 over the tangent. It's the inverse of those. It's a different thing altogether. Okay? And that's what they do is they plug in the ratio, you get the angle. If you plug in the angle, it gives you the ratio of the two sides. Okay? If you plug in the ratio, it gives you the angle. That's what you're doing on that. Okay? And that's what we're going to use to find missing parts. That's more of the same. I'm not going to worry about that. All right, here we go. Bonus round time. Find the missing parts of the triangle. That's what we're doing. If I have one side, and I was wrong, it's one side and one other thing, not two other things, one side and one other thing, I can find the other missing parts of the triangle. Now, like I said, in the triangle, there's 6 parts, but one of them in a right triangle, there's 5 that we don't know. One's given because that's the right angle. But if you have 2 of those other 5 parts, you can find the other 3. Some are easy, some are a little harder. Okay? So we have to find all the parts. First one I'm going to do, I'm going to find the other acute angle. Because that's the easiest thing to do. So, to make this easy, I'm going to label up my triangle. So we call this A, B, and C, which means that this is side A here, it's supposed to be an A, and this would be a C here, and this is the B that's already there. Don't need to do that. So, I'm given angle A. Angle B is easy, because what do these 2 angles have to add up to? 90 degrees, 180 for the whole thing, but 90 for the 2 acute ones, right? So that means angle B is 90 minus 66, which is 30 minus 6, which is 24. So my angle B is 24 degrees. Woohoo! I always start with the easiest thing I can, and if I'm given an angle, find the other one. Now it gets a little harder. Now you have to find one of the sides. And this is where your trig ratios come in. Okay? Now, you want to use given information whenever you can. Use the original given information whenever you can. Use found information when you have to. That's generally the rule. Okay? So I have angle A. I have side B. I need to find either side A or side C. So what I'm going to do is I got to go back to my trig function, my SOHCAHTOA. Some old hippie caught another hippie tripping on acid. So here's what I have to do is figure out what ratios I have that I have the parts for. If I use the sine, so I can use the sine, come on, stop doing it. Sine of 66 degrees is equal to the side opposite over the hypotenuse, which would be A over C. That does me no good, because that leaves me 2 variables in one equation, and I have to have only 1 variable in one equation. Okay, so let's set it up with the cosine. Cosine of 66 degrees is equal to 4 over C. I can use that to find C. For snorts and giggles, because that's not going to be an easy one, let's set up the tangent. Tangent of 66 degrees is equal to the opposite over the hypotenuse. Tripping on acid, TOA, opposite of our adjacent, sorry, which would be A over 4. Well, I'm going to tell you right now, don't want to use that. 2 variables, it's done. I can use either the tangent or the cosine to find either side A or side C. I'm going to tell you, or ask you the question, is it easier to work with the variable in your numerator or the variable in your denominator? It's going to be in your numerator. So here's what we're going to do. We're going to use the tangent. So the tangent of 66 degrees is equal to A over 4. And I want to solve for A. First thing I do when I got a fraction, get rid of the fraction, multiply both sides by the denominator. Multiply both sides by 4. So these cancel here, and I'm just switching sides. A equals the tangent of A equals 4 times the tangent of 66 degrees. And now it's a matter of plugging it into your calculators. 4 times the tangent of 66. .98, 41, blah, 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 blah. General rule, 4 decimal places for trig functions, 2 decimal places for a side length, 1 decimal place for an angle. Why they're all different, I don't know, but generally speaking, so if I'm looking for 2 sides, side A would be 8.98. I'm recording, so I can't stop and turn it off and turn it back on again. That worked yesterday. So I now have 2 parts. I have this angle down here. I have this side here. What do I need? I need that side there. I can set up a trig function for it. I can use one already set up. Or, why work that hard? Use the Pythagorean theorem. A squared plus B squared equals C squared. Literally, in this case, because we're using A, B, and C. A, which is 8.98 squared, plus B, which is 4 squared, equals C squared. And just plug it in your calculator and figure out what C is. Side C is 9.83. There you go. That's what you do. Okay. Now, we have to look at the other triangle because it's a little harder. I'm going to go ahead and label this up. A, B, C, there's my hypotenuse C. And this, ladies and gentlemen, decision-making time. Once again, if you have one side and something else, you can find the rest. The easiest thing to find at this point would be the third side, right? Because I got 2 sides, use the Pythagorean theorem, find the third side. Do the easy thing first. Trust me, you want to do the easy thing first. So that would mean that 3.5 squared plus 6.8 squared equals C squared. .5 squared plus 6.8 squared. Enter. Second square root. Second answer 7.64. C equals 7.64, so 7.6 rounding off. 1 decimal place. Okay, so we got the side. There we go. 7.6. Now is when things get interesting. It doesn't matter which side we solve for, or so I should say, which angle we solve for here. You pick one, and you go from there. Angle A. I'm going to pick angle A. Now, I have to use a trig ratio for this one. Remember what I said when we were talking about the first one? What do you want to use? Whenever you can, you want to use given information, not found information. What did we find? We found the hypotenuse. To keep it as accurate as possible, we don't want to use the hypotenuse. Of the 3 trig functions that we have, the sine, the cosine, and the tangent, which one does not use the hypotenuse? Which one does not have a hippie? The sine, cosine, or tangent? Tangent. So you want to set up a tangent ratio. So that's what we have to do. So the tangent, I'm going to pick angle A, because we're going to do that first. The tangent of angle A is equal to the side opposite over the side adjacent. 3.5 over 6.8. Here's the problem. We can't take the tangent of angle A because we don't know what angle A is. We have to use find angle A. This is where you use your inverse trig functions. If the tangent of angle A is equal to this ratio, then the inverse tangent of that ratio, come on, 3.5 over 6.8 equals angle A. That's how inverse trig functions work. If the tangent of an angle is equal to the ratio, the inverse of the ratio is equal to the angle. That's it. This is a very powerful tool. Now I can figure out what angle A is. So take your calculators, do that, calculate it out. Make sure you can do it. Just don't copy down my answer. Do it for yourself first. Parentheses are important. If you don't use parentheses correctly, you will get the wrong, or should get the wrong answer. Depends upon how smart your calculator is. But remember, calculators are dumb as posts. They're going to do exactly what you tell them and only what you tell them. So, angle A is 27.2 degrees. That's what I got. That's what you should have gotten on yours. 27.2. If you did it right, you should get 27.2 degrees. So that means angle A equals 27.2 degrees. Which means an angle B is 90 minus 27.2. Because if you use a trig function, you're only close to one decimal place, it's not going to matter. So 90 minus 27.2, and I'm using my calculator because I'm being lazy. Angle B is equal to 62.8. The absolute key to doing this is setting up those trig ratios. If you understand the trig ratios, sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent, some old hippie caught another hippie tripping on acid. You remember that? You set up those ratios, you can do it. The only other tool you might need is Pythagorean theorem. And honestly, like I said, if you have one side, and you have to have at least one side, and any two other parts of the 5, you can find the other 3. Or any other part. So there's 5 missing parts because one, the 90 degrees taken. You have to have one side. The reason you have to have one side is to give the triangle a permanent size. Because if you have 2 angles, there's an infinite number that has triangles that have those angles are just bigger and smaller versions. They're all similar, right? You remember similar from geometry? I'm sure you do. But if you have one side locked in, then you have one specific size. One side, one other thing, you can find the other 3. Using the trig ratios, using the Pythagorean theorem. Okay?